We carry supercomputers in our pockets that can answer almost any question instantly. To gain that convenience, we surrender our location, our search habits, and our biometrics to servers managed by third parties. Every time a device syncs to the cloud, it creates a point of entry. Our personal data sits in sprawling corporate ecosystems, leaving our digital lives exposed to data breaches, external tracking, and constant surveillance. This schematic represents Project Suit, a concept originally envisioned by a ninth grader. It is an external nervous system designed for survival and isolation. The entire mechanism is built around a single rule of absolute autonomy. It protects the user physically and digitally by functioning entirely offline, severing all reliance on remote servers. By stripping away cloud dependency, the suit suggests an alternative path for engineering. It proposes that the ultimate technological luxury is the ability to safely and permanently disconnect. Wrapping a human body in active circuitry creates immediate engineering hazards. The innermost layer must shield human skin from electronics carrying live currents just millimeters away. The base material covering that inner layer must be conductive and strong, but if it blocks airflow, the user would trap their own body heat and suffer heat stroke within an hour. This diagram illustrates graphene aerogels. Its mesh lattice structure creates microscopic pores that vent body heat while maintaining continuous electrical paths. It also maps power distribution. Exterior photovoltaic materials convert ambient light into electricity, reducing the draw on internal solid-state batteries. Along the outermost surface, an integrated grid of electromagnets acts as a modular attachment system. By routing a specific electrical pulse, the user can instantly snap specialized hardware, sensors, or physical tools directly onto the suit. By combining thermal venting, surface power generation, and modular hardware, the exterior functions as a self-sustaining generator that works in tandem with the human body. The hardware requires an operating system, and the primary constraint is total isolation. The internal network has zero connection to the global internet. It uses a strict whitelist firewall protocol. The suit acts as the master device, automatically rejecting all incoming remote signals and communicating only with local secondary devices that have been pre-verified and encrypted. This flowchart maps the localized 4-tier AI architecture. Tiers 1 and 2 handle audio-video formatting and insight extraction. Tier 3 tracks biometrics. Tier 4, the master CPU, applies multimodal data fusion, cross-referencing heart rate, GPS, and behavioral patterns to formulate autonomous decisions. This leads to a specific hard-coded safeguard. If the fused data indicates a severe medical or physical crisis, the master AI is programmed to execute an emergency override. It takes complete autonomous control of the suit's functions to preserve the user's life, even if the user attempts to manually disagree. By cutting off all cloud access and granting the master AI infinite priority during an emergency, the system acts as a localized guardian, engineered to save the user from themselves. Processing constant real-time data offline creates a physical bottleneck. Recording high-resolution audio and video every minute of the day would rapidly exhaust the storage capacity of a localized backpack drive. This animation shows the suit's daily sleep cycle. When powered down, the master AI processes raw data to fine-tune local models, extracting behavioral patterns and updating neural weights. Once learning completes, the heavy raw files are permanently deleted. This edge computing strategy keeps storage requirements low and acts as a security measure. If the physical suit is stolen while the user sleeps, an attacker finds zero raw footage. They only recover a complex set of encrypted algorithm weights tied to the creator's biometrics. The mechanical engineering handles the physical survival, but the underlying architecture points to a specific psychological motivation. It raises the question of why a person would meticulously design a system for absolute, uncompromising isolation. Programming an AI to override your own commands requires immense personal trust. The suit was built by one person, for one person, a bespoke environment designed for an individual rather than a mass market. This image reflects the archetype envisioned for the master AI, adopting the persona of Lucy. Drawing from popular media, this persona represents a digital partner that observes and anticipates needs without requiring explicit instructions. Navigating daily human interaction requires constant social filtering. The suit acts as a closed ecosystem where the user can think out loud, experiment, and process data without the burden of explaining themselves. The physical armor is the final step in a search for a private, unfiltered existence. It is a mechanical response to a deeply emotional need for safety. By coordinating physical armor, local AI, and biological memory management, Project Suit establishes a framework where a machine mirrors the specific biological and psychological needs of a single individual. Looking at this visualization, we see a stark contrast to the modern technological landscape. While current devices pull data outward into public cloud networks, this localized system confines computing power exclusively to the individual. True innovation lies in creating a private mirror that allows us to navigate the future entirely on our own terms. It demonstrates that advancement doesn't require integrating ourselves further into a global network.